We start today with the Python perspective and also working with line data because that's of interest for people doing research in UKCH data and synchrotron data. The first thing we were going to do is to switch to the Python perspective and try to use Python to run scripts directly. The first thing, if you use Open and you are in the data perspective, you can just move to the Python perspective if you have the button here, or just look it up there, clicking on this button and then looking it up on the list of perspectives here and clicking on Open. So this is the default of the Python perspective. And the next thing we should do is open the file plot.py. We have in the default data project that comes with the example files, we have a folder that's called src for source, and you just look for plot.py, which comes with the sample data. And this is the script that we can run. And to run it, you just have to click on this green button here, and you immediately start seeing this plot change because it's performing some operations. So the next thing we see is the explanation of what this Python perspective is. So we have the parts of the Python perspective here. This is the code view, which is the part where we write the script and the commands that we are using. This is the console. This is the plot view. And those are the main three parts of this perspective, the three main views that we are going to be interacting with. That's the run. And now we are going to quickly explore this script. This is a very basic script. So it has comment lines, which allow you to document the code. It has import statements, which tell the compiler to get some extra libraries. It defines two basic functions, and then the body of the script calls the functions, calls a sleep process just to wait a little bit between execution of the functions, and then writes a statement saying that the plotting has completed. So that's what we saw here when this program runs. So the first command plots a line, so calls this function. When I highlight this, it automatically highlights the definition, and if I leave my cursor there, it will tell me what this function is and where it is. So it's in the same code. So sleep is an internal function, is part of the one of the libraries. The library is time. So it tells me sleep found at time, and it gives me, it takes number of seconds as a parameter and so on. And then plot random, which is the second function. So that's the execution of the code. And we are now starting with line traces. We will use the data bin again, and we will take some data from one of the DAT files, which is the UKCH 115.dat, and we will try to plot it and do something with this plot. So the plot we are going to be using is the plot of the logarithm of I0 IT. So it says that we should move to the explore perspective, then look up at the examples and look for this UKCH data and open it. You double click or you use drag and drop here, and then it wants us to go to this plot, to plot this data, which is the L logarithm natural, the I0 IT. This is the data that we get when we click, and that's automatically plotted in this view. And if we switch back to the Python perspective, we can start modifying the code. So let's see. Then the next thing is open the file data plot py and save it as linetrace.py. We switch to done. Being in the Python perspective, we open plot.py and we go to file and save as, and this is the place where we want it in source, and this is the name. We it suggests that we use line trace. So line trace. So plot, and yes. Just by changing the name, we have a different file here. So it should appear here in your list of files in the source, line trace. If we don't change anything, the program will still run and do exactly the same that it did the last time. Okay, so the next thing is to start modifying the code. And the first thing is to create a new function. And this is the function to get the data. And in this function, we just put the statements that we already used in the previous session last week. So they want to set the foul view, the get data bin, and the data, getting the data from the data bin, and then returning this as two values, one x0 and y0, which will contain this data that we are taking from the default view. So this function will do these things in one go, and instead of having to enter every time these commands, we copy and paste under the definition of the functions that we already have. If we run it now, it should run without problems, but it doesn't do anything because we haven't used this function. The next thing that we are asked to do is to modify the code to use it. The first thing is to get the data using the function. So if we add these lines between, to this program, we can see this. This code calls the function get data view. It takes the name of the view that we want to set as default and from which we will be getting the data. So the default view is dataset plot. Then it gets X data and Y data, which is two arrays, passes these arrays, prints the arrays and their dimensions, and stops the script. So that's as far as we get. So if we try to run this now, it should run. It asks me if I want to save. I said yes, save please, and it does the things that it did before, and it ends with the printing of the X and Y axis for the data that we just got, but it doesn't plot yet. So the next thing would be to use this data that we got from the explore view, which is the data that creates this image. The next thing is to take these 4 lines of code, copy them and paste them underneath the current code. So copy, paste here. This way, what we are going to see is the change here in the plot one, because we are setting that as the name of the plot, the default plot, after taking the data. So we first take the data from dataset plot, we change the name of the default plot, and then we plot this line data into this space. So this is what is going to happen when we run. We run the code, and you see the previous behavior is still happening, and it really it changed quickly between the plot of the random data and the plot of this data, because we don't have this sleep time in between the X data and Y data. If you see, in here we have the name of the axis that we can change this, and the data that we are assigning to each of the axes. So that's how it works, and we are also passing the title for the plot. So that's all we are passing with this DN plot line, which is something that we already used here when we said plot line XY, but we are just giving more information to customize the way this looks. Up to here, we are there. And the next one is just a cleanup exercise, which is trying to get rid of the code that we are not using for after running this experiment. So for instance, deleting the functions that we used before, deleting the time import and this code, because our main objective in this one was to take data from that file through the DExplore perspective and use it in the script. So that's taking data from inside DOM and pass it to the script and then return it to DOM. This is the cleanup exercises. We can leave them as homework and then move on to the Nexus file, which is more interesting, I think, for the work that you are going to be doing later with data from the different beamlines. So for this, we move on to slide 34.